There's John Black, super chemist. There's no experiment today. It's just me talking about a soda lime decarboxylation. Now, decarboxylation, that means you get rid of a carboxy group or a carboxyl group. This is a carboxyl group. It's what makes a organic acid, right? You got your your carbonyl and your hydroxyl. If they're right next to each other and they're at the end like that, it's called a carboxy group. Soda refers to sodium hydroxide. Lime refers to calcium oxide. Decarboxylation refers to getting rid of this carboxy group. So all you do is you put these three things together and you heat them up with a torch. You don't want to do this with glass. Put it in a can or something, you know what I mean? Because you need a lot of heat. All right. Now, I'm basically guessing on all of this, okay, coming up here. I can't find any information about it, but it all makes sense to me, so whatever. I think that first of all, you got the sodium hydroxide, you got your acid. Obviously, you're going to have an acid-base reaction. What do you make when you got an acid base? You make salt water. You're going to make a salt of that carboxy. Let's just use acetic acid so we can have an example. So you have sodium acetate here, no, we use benzoic acid. So you have sodium benzoate, and you make water, one thing of water. Now you got your sodium benzoate, you got your water, you're still adding all this heat. The heat takes the CO2, that CO2 group there, makes it into carbon dioxide. The R group is missing an H now, though, right? When this carbonyl group goes away, carboxy group goes away, it needs an H there. Where does it get the H from? It gets it from the water, right? And now you're left with an OH and a sodium. So you got sodium hydroxide, right? So this will be distilled out as benzene, right? And the thing about this reaction is it can go back. This CO2 can react with your benzene now to make benzoic acid, what you originally started from, right? So you have to get rid of that CO2 so it doesn't react. The NOH, that helps, right? Because it'll make sodium carbonate, right, down here. And if you have the calcium oxide also, plus the CO2, you'll make sodium carbonate, and that'll scrub it up, and the calcium oxide will scrub it up and make calcium carbonate, right? That's pretty much it. You distill out your product and you redistill it. Dry it up a little bit or redistill it or whatever. Now I want you to look here down below. I don't know if it's on camera. I'm going to check. A lot of people, it seemed like maybe it was Now Red or something, did sodium. He started out with a salt. He didn't start out with the acid. He started out with the salt of the acid, right? And he put in sodium hydroxide. So he came all the way down to this right here. The thing about this is, and it's a good, especially if you don't have any calcium oxide, or you don't have the ability to get the calcium oxide, you know, it's a good reaction. But my belief, and this is just a guess, my belief is this is better. And the reason why is two reasons. One, calcium oxide is a better scrubber for CO2 than sodium hydroxide. Okay, and that's number one. Number two is if you look down here, there's no water, right? Where does the proton come from? Right? You don't have a proton because it was replaced with this sodium on the end here, right? When this CO2 comes off, where does the hydrogen come from? Now, I mean, sodium hydroxide always, I mean, unless you get lab grade stuff or whatever, but it usually has water. It absorbs water real quick. So, as a matter of fact, as a hobbyist lab chemist, usually you add on another 10% of any time you put in sodium hydroxide into something, you add another 10% to make up for the water that it absorbs. Okay? So I'm guessing that's how this reaction works. It gets the proton from that extra water, that the sodium hydroxide mixed up, you know what I mean? And you figure as it absorbs the CO2, it'll make some water here, you know what I mean? But to get it going at first, it's just extreme heat, and I think there is a little bit of water in there, you know what I mean? Or maybe it grabs water from the air also, you know. But this works on pretty much any carboxy group. Some carboxy groups you may have to have a catalyst to help get it off, you know what I mean? I made some, or I think I made some toluic acid, which is just basically benzoic acid with a methyl group on it. I'm going to do a decarboxylation with it so that I end up with not benzene, but toluene, right? Because I'll still have the methyl group on there. So anyways, I just wanted to go over this soda lime decarboxylation. I mean, you can also do this with, you can do it in any combination, really. I think another guy, I think Mist 32 or whatever his name is, I think he did it with calcium oxide and benzoic acid. But this is the original way. I'm assuming this is the best way. But like I said, I'm assuming. Anyways, you all have a great day, and always remember, science is great. I just wanted to show this new toy. Check it out. So you put the hose on the ends here. See there? Then you got an in and out. You can put your gases to come in, right? And then you put stuff down here, and it'll have to bubble through if it's a liquid, and if it's a come out here, and then it'll come out here. So you can see there. If you have solids, and if you have liquids, you'd have to put it in this way so that it goes down the tube all the way down to the bottom of the liquid, comes through the liquid, and then it can come up out here. This only goes to right here, this side. If you have a solid, yeah, I guess you do it the same way. You fill up your solids here, the gas would come in, it would be forced down to the bottom, and it'd have to go through all the solids, and hopefully it'd get, you know, absorbed by the water away from it, and it'll come out this way. Anyways, it's a nice little whatever. Fits the hose, is nice and easy. It's nice and snug too. So hopefully I can use that on something. Hopefully it will help with the gases. Anyway, y'all, good day.